Under the Mobil Serv offer, this video is a piece of the on-the-job training curriculum for mobile equipment inspection. The goal is to enable you to convert customer needs and opportunities around these activities into improvements in safety, environmental impacts, and productivity. The video is the first part of the OJT curriculum. After viewing it, you should job shadow a competent person completing mobile equipment inspections. Then, have the competent person observe and coach you as you complete an inspection. The OJT Participants Guide provides an effective way to guide the trainer and trainee through the experiences to gain knowledge and capability. Roger, a field engineer, has been working with this existing customer on a number of mobile planned engineering service projects. Josh, his contact at the mine, tells Roger that he'd like them to focus on inspecting some mobile equipment. He is particularly concerned with some equipment reliability issues relating to lubrication. Roger works with Josh to understand the impacts of any equipment lubrication problems, so he can later use this information to show how his findings and recommendations can reduce these impacts and produce value for the customer. To help bring solutions and value to his customer, Roger must be an excellent detective and must collect the data needed to plan and support the mobile equipment inspections. Roger and Josh have decided to conduct inspections on a 797F haul truck and a D11 dozer. These are examples specific to this customer. At other customers, these inspections could include loaders, graders, water trucks, drills, etc. Roger works with Josh to collect information on potential areas of opportunity, such as high lubricant consumers, high equipment repair rates, and potential suffering areas and root causes. Roger also reviews previous used oil analysis for oil condition and signs of wear and contamination. Then just before his site visit, Roger went over his safety preparations, like customer site-specific training. Many locations have, at minimum, a visitor orientation video. He also read through the Job Safety Analysis, or JSA, to review the risks and determine the best mitigation steps, including personal protective equipment, PPE. He prepares and reviews his toolkit, including clipboard or tablet PC or iPad, pliers, screwdriver, digital camera, flashlight. On the morning of the site visit, Roger and Josh first review their goals for the visit.
So, we made it to site today as we had talked about, and I think we'll try to get out and get onto that haul truck and that dozer like you discussed.
Absolutely.
Roger goes over his safety plan, and together they review the personal protective equipment they'll need.
Roger, we'll get you signed in. We'll make ourselves known to the foreman there. Check out the PPE, make sure we're all good there.
Hard hat, safety glasses, hearing protection, cut-resistant gloves, safety shoes, and flame-resistant overalls with reflective stripes. Not all sites require flame-resistant clothing, but you always should have high-visibility clothing.
Today we're going to be doing a lube inspection on this 797F haul truck. We've put our locks on, we've filled out our JSAs, and now we'll be heading on to the machine to do our inspections.
Roger uses this time to perform an additional safety assessment, identifying hazards and taking any necessary mitigating steps. Roger will keep his head in the safety mode during the entire inspection. Beyond concern for his own safety, Roger also actively cares for others, so nobody gets hurt.
Kind of key points we'll be looking at today is we'll be looking at the automatic lube system to make sure that it's operating, functioning properly. We'll also be looking at all the lubricated points, all the grease points. We'll be taking some oil samples today, hooking up some filter carts on this machine, and at the end of the day we'll be documenting all of this and hopefully put it into a nice tidy little engineering service report that we can pass on to the customer to show our value.
Roger begins inspecting the hydraulic system, looking at cylinders and checking for leakage, scored rods, or degraded wipers. He checks the condition of hydraulic hoses, looking for rubbing or leaking. How is their orientation? Are any pinched? He checks the kidney loop filter on the hydraulic system to see if it is properly connected to the system to ensure maximum cleaning capability. He verifies the cleaning performance by checking the lubricant's particle counts using Mobil Serv lubricant analysis. Here, Roger is inspecting the main grease pump, which is hydraulically operated. He wants to make sure that it cycles, that there are no leaks, and that it maintains the right pressure. Now Roger is checking grease injectors to pivot points for a support cylinder for the steering. He looks for plugging of the injectors. He also checks grease lines for leaks, breaks, or rubs. He inspects grease points, like this bushing, to make sure there is a good grease seal present around the bushing. He looks for excessive contamination or discoloration. Here he spots a grease pile from a leaking injector. This represents both a waste of lubricant and a potential safety issue. He looks at these injectors on the rear of the truck, again inspecting for proper operation, leaks, and good distribution to the lubrication points. Meanwhile, a plant mechanic prepares to take a sample out of the transmission. This is one example of checking to make sure that the customer is taking samples in the right way. Roger would also observe the practices for the other sampled components of the truck, such as hydraulics, final drives, and engine. They have chosen a good sample point to obtain representative samples, and of course, every oil sample will be labeled to capture data, including equipment number and name, and oil in service. Next, Roger inspects the wheel drives. Later, he'll inspect drain plug magnets like this one, looking for indications of metal wear. He goes on to look for leaks, and if the lubrication systems or reservoirs have breathers, Roger will check to make sure the breather elements are in good shape and are not plugged. Roger inspects the storage and handling of the lubricants for these trucks. He looks over lube supply hose reels, checking their condition and labeling. He notices some caps missing. Meanwhile, members of the plant maintenance team remove air filters and pressurize the air intake manifold. They're checking for leaks in the air-to-air after-cooler system. They should inspect the gaskets on these main filters to ensure that dirt is not passing by them. In addition, they will check cyclone pre-filters to make sure they are clean and not plugged up. Here he's spraying a liquid soap on all joints and connection clamps. When pressurized, if there's a leak, that soap will bubble up. After completing his inspection, Roger will record his observations and insights using a checklist like this one. He will compare his findings with issues of equipment reliability the mine has experienced. For instance, his discovery of broken or leaking grease lines or malfunctioning injectors may correlate with the failure of some equipment components. Roger will make recommendations to help improve the mine's total cost of ownership.
Today we'll be taking a look at a D11 dozer here at site. So basically what we're going to be looking at is all the lubrication points on this machine, kind of dealing directly with the manual lubrication greasing points. And we'll also be looking at final drives, the magnets, we'll be looking at breathers, we'll be taking a look at the air intake system, and also paying close attention to anything else that takes an oil or grease on this machine.
As he did before, Roger begins his inspection of the dozer with an additional safety assessment, identifying hazards and taking any necessary mitigating steps. Roger will keep his head in the safety mode during the entire inspection. After putting his personal lock on the master control box, Roger climbs up on the rear of the dozer to check the hydraulic system. He checks the oil sample port for hydraulics. Then he inspects the hydraulic hoses. Are they too loose or too tight? He notes that these hoses should be tied up or separated in some way. He also notices some leakage going on. This leak from the fuel line is pretty obvious and could pose a safety issue for the customer. Then he notices missing fill caps that may allow contamination to enter the lubrication systems. He checks that there is a grease seal here on the cylinder bushing for the ripper. He checks to make sure the grease seal is sufficient to keep contamination from entering the bushing. Roger will check the carriage tensioner on the track and this carriage bushing to ensure that the proper grease amounts are reaching the components. Then he looks at the final drive magnetic plug for the carriage drive. He wants to see if excessive metal is built up on the magnet, indicating potential excessive gear or bearing wear. Roger climbs up the side of the dozer to check the hydraulic oil level and the kidney loop filter for the hydraulic system. He will continue to check the other lubrication system's lubricant levels. Here, he checks the air intake to the engine. If he suspects dirt, he will pressurize and look for leaks. These are oil filters for the engine and a sample port. He inspects these to ensure proper contamination controls are in place. Roger pulls the air intake cover, looking for dirt traces. He'll check the gasket to see that it's not deteriorated. He then checks the engine radiator to ensure that there is not excessive dirt buildup that could result in lubricant overheating. He checks the engine oil dipstick to ensure that proper levels are maintained. He also looks for obvious contamination signs, like milky oil on the stick, which could indicate a coolant leak. Finally, Roger completes his notes for the dozer inspection. Later, he will combine these with his photos and other data to prepare an engineering service report for his client. After his haul truck and dozer inspections, Roger meets again with Josh to explain his preliminary findings. He tells Josh that he will combine his findings, including measurements and photos, to prepare an engineering service report for Josh and his supervisors. He must take in all the facts and sequence of events to determine potential root causes of any problems he finds. He must work with his customer in cooperation, not only to gather the information, but to form the recommendations that will produce the best value. Roger will correlate his findings, plus a Mobil Serv lubricant analysis, with inspections of the components that Josh thinks are causing reliability problems. In this way, Roger will address Josh's concerns by offering insights and recommendations that can be justified by total cost of ownership. Roger can demonstrate that his findings and recommendations produce an excellent return on investment and value to his customer. Roger and his sales advisor will use this report to promote our value to other key contacts at this customer. If very well received, this engineering service report could become the foundation of a proof of performance from this customer that could be used to show other customers to convince them that ExxonMobil and its distributors are the right lubricant supplier for them. In addition to helping this customer in this one application, Roger will look to see how he can help the customer apply what they have learned to other similar machines at this facility or across their entire company. By using the standard operating procedure as a guide, as well as the other tools described, Roger can consistently conduct these studies and deliver outstanding value to his customer.